Hi, my name is Nurul Husna and I'm the first presenter for my group. We have chosen product ATIVA 1.0 Turbo for our project. We consist of 5 members which including me, Arifah Kurazi, Muhammad Amir Hafiz, Muhammad Harif Ikhman and Muhammad Naim. First, I will present about the objective. We have to illustrate why our selected vehicle, Product ATIVA 1.0 Turbo, is the greatest EEV car in this period. Model clarification, model analysis and model improvisation may all be part of our project. We may utilize the Ahmed body to analyze the model in CFD and focusing on lift and drag coefficient. Second is scope and background of the project. We have been tasked with selecting one model based on the qualities of EEV car. Model analysis will be carried out during the course of the time allotted to complete this research project. The obtained result will be compiled to demonstrate that the chosen model is an EEV. According to EPA, one conventional passenger vehicle that travels about 11,500 miles per year and gets 22 miles per gallon emit rough about 4.6 metric tons of CO2 into the atmosphere each year, while the exact amount of greenhouse gas emission from a vehicle varies depending on the total number of miles driven each year, as well as the vehicle fuel type and economy. Switching to an electric or hybrid vehicle can help to improve the environment, improve public health, and save money on fuel costs. In accordance with technology advancement, EEV has been implemented in Malaysia. EEV is technology agnostic and applies to all sorts of powertrains, as our emissions have to be tested and confirmed at a quality lab at the manufacturer expenses.
My name is Muhammad Naim Yaakob, MH1018. Today I will explain about the electric vehicle explanation. In this fundamental form of electric vehicle, all four wheels are utilized. The name for the configuration where two wheels are connected in the front and is front wheel drive. The differential serves to connect both wheels at the end of the axle. In the model of electric vehicle, the power source is represented by a battery pack, a lithium-ion battery that is permanently installed in the modeling of an electric vehicle and serve as a source of input supply for both the motors that are connected across the front and rear ends of the model. Okay, this is the simulation of electric vehicle. The simulation result of the both control for example with and without OR optimization, analyzed to show the feasibility of the proposed EV drive system model. The speed and the torque of control EV is executed through the torque distribution in front and rear wheel drive by the following running modes. Okay, next is the hydrogen fuel. Hydrogen is a clean fuel that generates just water when used in the fuel cell. Natural gas, nuclear power, biomass, and renewable energy sources such as the sun and wind may all be used to make hydrogen. One of the reasons why hydrogen fuel cell cars are promoted as the greatest alternative to contemporary EV is their significantly greater driving range. Hydrogen fuel cell vehicles are extremely similar to electric vehicles. They store energy in the batteries and use the energy to power electric motors, such as those used in EV. The difference is instead of the charging of the battery through wire and charge station, hydrogen fuel cell vehicles fill tank with highly compressed hydrogen. The hydrogen interacts in the fuel cell, producing both water and energy. Okay, next I will explain about the EV concept and technologies. We have four types of electric vehicle. The first one is the BEV, battery electric vehicle. Use electricity to charge the vehicle battery. The electric motor is then powered by the battery, which move the vehicle forward. There are no tailpipe emission because the vehicle does not burn fuel to move. The second one is the plug-in hybrid vehicle, which is PHEV, which combine gasoline and electricity, have an internal combustion engine, a battery and electric motor, and a gas tank. Fuel source for PHEV include both gasoline and electricity. Next is the hybrid electric vehicle. Similar to PHEV, they have an internal combustion engine and the electric motor to power the vehicle. Regenerative braking, which cover energy normally lost during braking to support the gasoline engine during the acceleration, provide all the energy for the battery. And the last one is the fuel cell electric vehicles. Such a vehicle are powered by hydrogen. Rather than being burned in combustion chamber, similar to conventional ICE, the hydrogen gas is fed into an onboard fuel cell stack that convert the chemical energy of the fuel into electric energy compared to conventional ICE. The waste product are water or H2O.
Hello, good evening everyone. My name is Muhammad Haris Iqmal and I will continue to present uh, about vehicle modeling and simulation 3.4. Okay, this is the Ahmed body of the car. The Ahmed body is using the specification of our chosen model, which is Pro 2 ATIVA. We set the air velocity to 30 km per hour, and as we can see from figure, there is figure for cut plot, surface plot, and flow trajectories. We can observe that the frontal area has highest pressure, which is 101 kilopascal, and the lowest pressure at the back is 100 kilopascal. Then we proceed to design a product ATIVA in SolidWorks. The dimension is the length of product ATIVA is 4065 millimeter. The width is 1710 millimeter, and the height is 1635 millimeter. Using the SolidWorks, we designed the product ATIVA and did the CFD simulation. And as you can see from figure, cut plot, surface plot, and flow trajectories, the frontal area has the highest pressure, which is 102 kilopascal, and the back is 100 kilopascal. 3.5 design improvement. We added part which is spoiler, because spoiler are designed to alter the airflow over, around, and under moving object in order to lessen drag, to increase downforce, and grip at high speeds. They are intended to spoil the airflow in order to lessen its dramatic effects. So after the spoiler is added, using the SolidWorks, we use the simulation, CFD simulation. As we can see from figure, we can see that the highest pressure is 102 kilopascal and the lowest pressure is 100 kilopascal. That's all from me. Thank you.
My name is Muhammad Amirul Hafiz bin Kamar Azmet and my ID is MH1013 and I will present about the chapter 4 is the discussion. First is the performance criterion. They have a three type of the criterion. First is the horsepower. An electric vehicle may give the impression or more power than the vehicle power by internal combustion. Secondly is the top speed. Many electric automobiles are perfectly capable of achieving speed more excess 100 miles per hour. It is possible the electric vehicle, depending on the manufacturer, have a top speed is marginally lower than gas power automobile. Lastly is the acceleration. Electric vehicle have speedier acceleration time than gas power vehicle to become because electric automobile have immediately torque, which means that the motor is running power for power the wheel. Secondly is the road load characteristic. The road load characteristics are a critical aspect of the vehicle design and performance and play a significant role in determining the vehicle fuel efficiency and overall performance. They have three characteristics. First is the aerodynamic. Drag is one of the most important. Secondly, is the tire roller resistance is also is another important because this of the force that oppose the motion of the vehicle tire as it rotate on the road. And lastly, the gravitational force. Next is the target energy consumption per vehicle. They have three target energy consumption that can be used for the future. First, the government around the world have set the fuel economy standard for the vehicle. Secondly, is the industry organization also set their own energy consumption target. Thirdly, to optimize the design of the vehicle, achieve target energy consumption, include the lightweight material, aerodynamic design, advanced powertrain, and such as hybrid or electric drivetrain. And lastly, the manufacturer may also set their own target for consumption per vehicle as part of their sustainability goal and improve their competitive in the market. That's all from me. Thank you.
For conclusion, the Port 2 ATIVA is the best EEV vehicle to utilize. Based on the qualities displayed by ATIVA, practically all specifications completely meet the parameters required to be the best EEV for this age that is suitable as a family car. There is no question that hybrid vehicles are better for the environment than traditional cars powered by internal combustion engines because all the cars have their advantage and capability. That's all for us. Thank you.